Arcsine? Actually, it's easier than that. What's cosine squared theta plus sine squared theta? Uno, right? Yeah. You'll see it rewritten a few ways. Sine squared theta is going to be 1 minus cosine squared theta, and you're going to see cosine squared theta written as 1 minus sine squared theta. So when you see 1 minus cosine squared theta, you're going to make this direct substitution. The caveat to this section is it seems super, integration by parts. Is integration by parts super helpful on a lot of different types of situations? It's really, really helpful in a broad space. Trig substitutions are pretty limited. For example, if you were going to do the indefinite integral of 1 over the square root of 1 minus cosine squared theta d theta, it looks structurally pretty nasty, but what can you substitute? That's going to be sine. Well, not sine, it's going to be sine squared theta, which will reduce
1 over sine theta.
Hold on. What is this equal to? That's all I'm asking right now. Yes. This right here is equal to, so we're going to carry it down to equal to 1 over the square root of sine squared theta d theta. And does that simplify?
Yes.
Yeah, it ends up being 1 over sine theta d theta, which ends up being integral of sine to the negative 1 theta d theta. Is that something you theoretically, sorry, that's not what I meant to write. I meant to write sine. Is it really important that I put that exponent? Inverse. It's not inverse. It is not inverse. Now, is that something you could anti-differentiate in your head? What was the specific structure to this integral that made it so we could actually do this really straightforward trig substitution? What was the structure that was really nice? 1 minus cosine squared. To be more specific, it's 1 minus something squared. 1 minus something squared. So our section in 7.4 really comes down to figuring out where do we have 1 minus something squared. If we can create 1 minus something squared, we're good. We're really good, because do we have something we can do with 1? Oh, we can do a substitution and it collapses. What was the other part of the structure here that was really nice? The square root was really nice. Because is it trivial? Is this trivial or kind of nasty? That is not trivial. That is not trivial, because what do you have to do to integrate sine squared? You have to use integration by parts. You have a place to go. What? Twice. Okay, yeah, you've been by parts twice. So the point is there's a big difference between trivial and not so much. Algebraically speaking, you will see things that look like this. Let's put it like that. A. Let's make it A. Yeah, do we like it? Hold, I'm still talking, James. Let me finish my sentence here. Is that close to what we want?
Yeah. Yes.
What are we searching for again? We're searching for 1 minus something squared, right? We're 1 minus something squared. It'd be nice if it was clean, but it doesn't have to be. Is this 1 minus something squared? No. So algebraically, what are we doing here? What would you call what we need to do?
Take 1 over square root of A.
We're not distributing. We're doing kind of the opposite of, we're factoring in a way. What do you have to be really careful of if you're factoring this? You have to be careful of two huge things.
Square root of A.
You're factoring across a square root.
And 1 over.
And it's 1 over that thing. It's really easy to factor these wrong, and then you get very sad, you spiral. You want to turn this into a 1, so what do you need to pull out of that? What do you need to pull out?
A. You put out A, but you put out
Do you pull out it? You want to pull an A out of it, but if you cross that A over the square root sign, what does it become? Square root of A. So you end up with the square root of A times, that is correct. Now, that's not a parenthesis, right? The square root of 1 minus what, though? What do you end up with? 1 minus? Yeah, x over A squared. Or is it that? It's x squared over A. Thank you. There you go. X squared over A. Now, are we closer to what we want?
Yes.
We're closer to what we want, but I just actually made the mistake that most people would next make. You want to make it 1 minus something squared. Is that 1 minus something squared? A piece of that is squared, which makes it easy to pull out. Is this thing squared? Well, is anything something squared? Is anything technically something squared? When you're in Algebra 2, they tell you certain things aren't factorable. Is that true?
No.
No, it's not true. They're just ugly and nasty and disgusting, right?
Yes.
What does this become? 1 over the square root of a times the square root of 1 minus x over what?
Square root of a.
Squared. Do we now have something squared?
Yes.
So what was the moral to this story? If you had to give a one-sentence moral to this algebraic story, what would you say it is?
Okay.
Be careful. You guys know what you need to do, and you're very confident with your algebra, but it's super easy to mess these up. Okay, now get out of here.